Developing on a new hardware is much easier these days. The platforms are much more flexible and universally available for developers to add onto those platforms. One of the most noted ones is the Arduino. So, Massimo, could you tell us a little bit about the Arduino platform and also the company that essentially backs it?
So Arduino is essentially was born as a prototyping platform originally. So something that combines a microcontroller development board, a development environment, a simplified framework for developing with C++, and also essentially a method for teaching people how to use microcontrollers. So there was this. It was originally born for students of design, so they don't necessarily have a deep understanding of electronics and programming. So it was something that would get them up to speed very quickly. And one of the things that we noticed after the initial sort of birth of the platform is that actually a number of people who develop professionally were using it as a way to get their ideas done very, very quickly. And so it became very, very popular in develop as a prototyping platform for, if you look at most of the Fortune 500 companies, they use Arduino for prototyping, for innovation, for ideas. And they also, if you look at LinkedIn, you find probably more than 500,000 people, last time I checked, that have Arduino as a skill or as a keyword somewhere in their profile. So it's quite a journey. Then obviously this started off as an open source project, but then people wanted to just buy the hardware and use it. So we created a company that is based in different parts of the world. Most of the R&D is made in Italy, and the manufacturing is made in Italy. One of the most interesting thing about Arduino and the company behind it is that we continue to release everything we do as open source hardware and software and Creative Commons for the documentation. But in the last few years, we noticed a bunch of people starting to use Arduino in industrial applications. So we created a new part of the company called Arduino Pro, which follows those customers, and we have now more than 1,000 customers that are basically companies using these industrial products in either industrial automation or embedded development.
Okay. Well, the latest platform you have is the Uno R4. We'll get into the details of the two versions that you have. Could you first, though, talk a little bit about the compatibility between this platform and even the original?
Yeah, I mean, the original Arduino Uno was an 8-bit microcontroller, which when we started working on it was a great solution, probably one of the best at the time. It proved to be like a very robust platform, and also the processor is very simple, so it's very quick to develop on it. But obviously, as the years progressed, we added a bunch of other boards. Now we have dozens of different boards, and about 10 years ago, we started to adopt heavily the ARM processors. So basically, this Arduino Uno, which is our kind of entry-level platform, was one of basically the last one that was left on 8-bit. So we thought that it was time for an upgrade. And so but we had a bit of a challenge, because obviously the people who are using the Arduino Uno, they are expecting, for example, to use electronics at 5 volts, which is kind of the standard that we use at the beginning. And so to find an ARM processor that works natively at 5 volts and has a native USB port, it's kind of challenging, but luckily enough, one of our partners is Renesas Electronics, and they had such a part. So that was a good starting point for us to look at how to build. And also we kind of took 2 directions. So we realized that now a lot of people expect to have Wi-Fi and Bluetooth for that project. So we created a version of the new Arduino Uno, we call the revision 4. The previous one was called the revision 3. So the revision 4 has native Wi-Fi and Bluetooth and a few other interesting features. And we also created a minimal version, which is kind of similar to the old Arduino Uno in a way, that only has the processor. But we upgraded, for example, the connector to USB-C because people now want, USB-C. So the idea was to create something that would be way more powerful than the 8-bit version, but compatible as much as possible with the old 8-bit version. So we did quite a bit of work, and we also had like a beta program with a bunch of users, notably people who write libraries for Arduino, to try out so that we could kind of work out most of the compatibility issues before the users put their hands on the platform. And we also, try to innovate a little bit on the platform. For example, we, in the Arduino Uno with Wi-Fi and Bluetooth, we also added a small LED display on the board because some of the users always wanted something that could display information on the hardware. And for many, many years, the only thing we had was a small LED.
Okay, so why don't we dive into the Uno R4 Minima to begin with? It has some support, for example, as a CAN bus. It also has USB interface support. Could you talk about that?
Yeah, I mean, one of the interesting thing about this this platform is that it combines some of the things that before we used to do with multiple boards. So, for example, many years ago, we launched this board called the Leonardo, which had the feature that the processor had native USB, and that allows you to do things like simulating a USB keyboard, simulating a mouse, even simulating more sophisticated HID devices. And this is a feature the users really like. So also because in certain situations, if you want to interface certain softwares with hardware, some of the softwares that you have on your computer might not have any other way of interfacing other than keyboard and mouse. So by simulating a keyboard and mouse, you can actually instrument or send data to softwares that don't support any other way of interfacing. So it's quite, for us, it was important to find a way to combine all these different kind of, let's call them legacy products into one platform. So I would say the Minima, I really like it because it's a very, very basic board. There's only like the processor. Obviously, there's USB-C, so you get also like a wider range of voltages that you can use to power the board. So, you can take advantage of the various USB power supplies. Also, there is the possibility to, so we also expose this JTAG connector. So it is possible using our IDE, the update will come out soon, but it will be possible to essentially debug the code on this board at low level, stepping through the code. So using modern debugging tools, which is also something that we wanted to do. Also, the other interesting side effects is that you get better ADC conversion. So the quality of the analog to digital converter is better. You get an actual digital to analog converter. So people used to do a lot of music on the 8-bit processor, but they only could do it by using PWM on a digital pin. The board didn't have analog output capability. Mm-hmm. So with an actual digital to analog converter, you can actually generate actual waveforms in good quality. So I think that's another interesting feature. It also supports CAN bus, which is something a bit unusual for like for a platform that is born as sort of like a maker / sort of prototyping board, but it's actually quite useful because obviously you can interact with something like your car. So you can interface it to your car and, you can also do damage, honestly, but if you're careful, you can do interesting projects that involve cars or trucks or, and, but also in some industrial automation, context, they now use a version, a flavor of CAN bus as a field bus. So it's also possible to create a very simple and low-cost node using this Arduino. It also has some much more sort of sophisticated things. There is an op-amp that you can actually connect internal to the processor, that you can connect to the analog inputs, but that's a bit of a more sort of esoteric function. But I would say already, you know, it's a much faster processor with a lot more features, but it is hardware compatible with every shield adapter that people have. So I think it's a very good compromise.
Very good. Now, one of the other things both of these have is that input power can be up to 24 volts. That sounds like something that would be very useful if you're actually going to put this into in the field.
Yeah, I mean, one of the other advantages also working with like USB-C is that, you know, some of these power supplies have like extended voltage ranges. We also added the classic barrel coaxial connector that we have on every Arduino, so that you can use a more conventional power supply if you want to. But 24 volts really enables integrating this device maybe into an existing piece of equipment that runs a lot of professional equipment runs that voltage internally. So I think it opens up the possibility of using it for this kind of applications without having to build extra power supplies, no? But even just to drive LEDs, for example, maybe not at 24, but there are some drivers that operate at maybe 12 or something volts. So it's natively available. So it's I think it's again, it adds functionality, avoiding people having to add more, you know, specialized power supplies or something, because the previous voltage regulator we had on the board was I don't think it allowed way more than 12 volts. So now you have a much more freedom on what you want to use.
Okay, so let's move over to the Wi-Fi version, which is more substantial, but it's actually in the exact same form factor.
Yeah, I mean, one of the interesting things of what we've been working on in the last few years is the fact that obviously people want to build more and more connected products. And one of the things that we also did in the last few years to create an IoT cloud platform that makes it, in my opinion, very, very easy for people to develop connected applications. We also have a mobile app that you can interface with this cloud, so you can kind of interact with the devices from your phone, from your browser. You can do all sorts of interfacing, but if you use an official Arduino product, it tends to be much, much easier to connect. So we needed something that would have connectivity, so Bluetooth and Wi-Fi. But I think so the Wi-Fi module is based on ESP32, so a classic platform. So one of the things that we noticed is that a lot of people obviously like to use ESP32 sometimes directly, but it seems to be a little bit more complicated for some users, because sometimes the compilation seems to take very long or fail, or some libraries don't work incredibly well. So we noticed that in some of our products, the fact of having one processor that just runs your code and the ESP32 running as a Wi-Fi module works really well. It's very, very stable. So this dual processor architecture, it's actually gives you an extra level of reliability. And so we already use the ESP32 as a Wi-Fi module in a range of different products. So it was quite sort of natural to use it on this one. And yeah, so with this particular product, you can create connected applications. You can connect to different types of clouds. So I think it's it simplifies the connectivity again in the classic format, because if you look at some of the things that people are building, they maybe have an Arduino, then they have modules, then they have another thing that just gives it Wi-Fi connectivity. So I think with this architecture, you're reducing, you don't need a specialized power supply. You don't need an external Wi-Fi or Bluetooth. It's the one board that does already a lot of the things that you need.
Mm-hmm. Now, you mentioned already the LED matrix, and also the runtime diagnostics are improved on this platform. Can you talk about those two and their relationship?
Yeah, I mean, obviously the ESP32 is being very capable, can be used also as some kind of let's say programmer platform for the main processor. So obviously, if you use this version, you can directly interact with the main processor, and I think it opens up a lot of other capabilities also in debugging the code running on the main processor, which, for example, I think for an educational setting, it's actually quite good, because obviously for the good part of Arduino's history, most of the people debug by printing data onto the serial port, which is great for certain use cases, but effectively, if you're trying to teach people how their code actually runs, it's actually very good to have this capability of stepping through the code out of the box. And so our Arduino IDE 2.0 supports that. So all the pieces are coming together for that. And I think that was also something that people, a lot of in this Arduino Uno R4, there is actually a collection of things that people have asked over the years, just implemented in the new platform. So some people want just a bare bone platform that's cheaper. Somebody wants like a full featured platform with a bunch of different things. So there are two versions. And also, some people have asked for USB-C, people have asked for better output, people have asked for better performance, and then also, debug capability. So this platform in the two versions tries to cover all of those requests.
Mm-hmm. Okay, now typically the expansion has been in the stackable shields that you can use on all the different Arduinos. And you also added the CAN bus support you mentioned for the Minima, which is on the Wi-Fi version 2, I think. Yeah. But there's also another interface that has been used quite a bit, I2C. And you have a quick connector on the Wi-Fi version. I'm not sure if it's on the Minima version or not, but could you talk about that?
It's only on the Wi-Fi. Well, basically, we have been experimenting for years with using I2C as a bus to connect different types of sensors. In fact, a lot of the other connected products in Arduino have a connector that brings out I2C plus some other signal. But then obviously what happens is that we notice that makers are now using a lot this connector that Sparfan calls Qwiic. I don't know if that's the correct pronunciation, but that's how it looks like. And so we decided to adopt that one on this particular product, so that if you have several I2C sensors and actuators on modules, you can actually connect them to this particular connector on the Uno R4 Wi-Fi. So you can actually connect a sequence of devices to the same 4 wires. It's a different way of creating applications, but it also opens up the door to interesting combinations. So for example, you could put, we have, the market has a number of motor control shields for Arduino. So you can put them on top of the board, but then you can use the I2C connection to connect different sensors, or for example, the other day I was playing around with this module that has like a quadrature encoder. So you can actually basically build the UI for your project on these modules connected with the cable, and then as the motor driver on top of the board. So I think it's a nice combination of interfaces, and it opens up a bunch of other possibilities. So it's good.
Now, the development platform has been improving over time. It's not necessarily the only way that you can work with the boards, because you can also use third-party tools. But talking about the Wi-Fi version, will the standard development platform allow you to essentially do wireless programming and debugging?
Well, you can. So so just so let me start.
Okay.
So yeah, so one thing that we've been doing, so our regular development environment, a lot of people love it. It's been around for a long time. So a few years ago, we started this process to create a new one, which is what we call version 2.0 or something. And that's a much more modern development environment, which is based on the same framework as Visual Studio Code, but it has a lot of these features that are specifically Arduino. So one of the things that people do all the time is search for libraries. And so the interface is incredibly simple. You press a button, you type the name of whatever you're trying to use, and it tells you all the libraries that work with you. So those kind of user experiences are embedded in there. So obviously, if you connect your devices to the cloud, you can actually also wirelessly manage the board remotely. So we have different capabilities with that. But I would say the main development environment now, the 2.0, it's a much better, much more professional tool that has debugging and all of that. And also one of the nice features that I want to kind of mention is the fact that if you have an account for the Arduino cloud and you have a bunch of programs stored in your cloud account with the current 2-point-something IDE, you can log into the cloud from the IDE. So you can see the programs that you have stored locally on your computer, or you can see the ones you have on the cloud, and you can check them in and out. So in a way, the user interface on that particular experience is much better.
Okay. One thing I forgot to mention is the capacitive touch support that this particular platform now has.
Yeah, I mean, obviously there are libraries that allow you to use some of the pins as a capacitive touch sensor, which is again another nice addition because you can create very nice interfaces with very little effort. And I think that's also something that a number of our users like. So there's still quite a lot of users in the Arduino community that, for example, build interactive installations for events, museum. They build interfaces for musical instruments. So a lot of them use capacitive sensing to create surfaces that you can touch, that you can interact with. So it's nice that now the capabilities are in the platform itself.
Okay. Now, you mentioned the professional support that you've been doing. This is one that is also supported in that. And could you talk a little bit about why you chose, for example, the particular Renesas part and how that sort of meshes with the professional development support?
Yeah, so I think one of the things that we were looking for was the ability to stay compatible with everything that we had from an electrical point of view. And obviously the classic Arduino is an 8-bit platform running at 5 volts. And there are situations where newer boards are running at 3.3 volts. Some of the users might not be fully aware of the issues.
Mm-hmm.
So they might try to connect sort of higher voltages to the pin. Some processors can get damaged with that. So we needed something that could run natively at 5 volts and that would have obviously an ARM processor, because this is what we work with right now, and also have a native USB connection, because we wanted to have native USB capabilities. So in the end, we ended up, looking through our partners' catalog, and we found that one of our partners, Renesas, that we work more and more closely, had a perfect part. So we started to use it. And it gives you a lot of benefits because you have a Cortex-M4 processor, so you have much better performance in certain activities. Not even because the processor is 32-bit native, but the Cortex-M4 has a set of instructions that accelerate a number of operations. So, in my opinion, it's a very nice combination of trying to stay compatible with everything that you have and get a better platform. For example, the Arduino Uno, the current 8-bit Arduino Uno, is used a lot by people that make small CNC machines, or even like, plotters and but it's a limited, what you can do, it's limited in the case because the processor doesn't have a lot of computing power. So with this, they can upgrade those projects without worrying about the fact that their motor controller is running only at 5 volts. They just plug it in and adapt the code a little bit, and it works. So I think that gives that interesting combination. It's not very easy to find a processor that is ARM Cortex-M4, but it's also 5 volts, but it also has USB.
Well, great. I'm looking forward to actually checking out the version of the boards that you sent for our kit close-up series. I wanted to thank you for filling us in on the Uno R4 and Arduino in general. Thank you.
Thank you.